on that using that method, one question I have or example I have shared that. So same example here. So earlier method that is you are telling fixed biasing method. So in this method, what I told, same thing, RB and RC are there. So this derivation we have seen earlier. So based upon that, have you solved this question or not? Or any queries in this? Or you due to exam you have not done this?
Yes, sir.
Please let.
Yes, sir, we have not done this.
Okay. So for that once I am repeating the process what to do. So then if you remember this for this method, so other method you are doing the same process. So whenever you are getting this type of question, first you have to, because this is this is the complete circuit. For DC biasing, first you have to, first step one, I'm writing it here. Step one, redraw the circuit. Redraw the circuit using DC biasing method. So what is that? If you are doing DC biasing method, so what will happen? Anyone remember? So whenever you are going for DC biasing, so the capacitor will be act as open, and your AC input supply voltage you make it, or you can neglect, or you can make it zero. Only DC sources will be available in the circuit. So this step, you can see this will be removed. Okay. So then you have to redraw the circuit. So this circuit will be only there. So in between you have to respond, because sometime network is I am not in the network and I may continue. Okay, so in between you have to respond one by one. Anyone you can respond.
Yes,
So
sir.
this is step. Okay, so this is step one. You have to redraw the circuit. So this is only DC sources will be available, and whatever other registers are there, it will be there. Now already this VB also, this is a constant voltage, you know. If any germanium or silicon transistor will be given, so accordingly you have to write this value, 2.7 volt. So VB is 0.7 volt. Now what is the next step, anyone? So first you redraw the circuit. Okay, second step. Anyone?
Divide that VCC and apply KVL.
Okay, you are telling because VCC you can separate, otherwise you can make it there.
Separate the VCC and apply KVL.
So here then you have to, because that's very important, next point you have to find the IB. Next point you have to find what is your input current. Find IB. So as you told, to find IB, so you have to apply KVL. So apply KVL in the input loop. So input loop means if you're separating, or you can see input, so you can say, because this is supply voltage and this is ground. So now current will flow like this. Are you getting me? So you can see, because this is supply and this is ground. So this is your input loop. So if you're applying the input loop, what will be the formula? So VCC minus IBRB minus VB is equal to 0. All are agree with me, or any deviation? So then you have to find out IB. So IB is equal to VCC minus VB divided by RB. Hello, am I audible?
Yes, sir.
Yes,
You're
sir.
audible.
Yes,
Okay.
sir.
So this is your IBQ. So in the circuit, using the different available sources and resistance values, you have to find out input current. Okay, this is your step 2. Then step 3, what is step 3? Anyone? So once you've got IBQ, so then you have to find out, because based upon the input you will get IC. So IC is equal to eta IBQ. So this is the third step you got. Now fourth step means you have to find out the output voltage. So you have to step 4. So you have to apply the KVL in the output loop. Apply the KVL in output loop. For what is the objective? Find VCEQ. Okay. So if you apply the output KVL, what is the formula? Now this supply voltage and this is your ground. So supply voltage VCC minus ICRC minus VC is equal to 0. Now VC is equal to how much? VCQ is equal to VCC minus ICQ and RC. Clear? Any queries? Is it clear?
Yes,
Hello?
sir.
Okay. So now this is step 4 to derive up to this one, IBQ, ICQ and VCQ. Then you have to find out next VB. VB how much? This is your VB, means this point is VB, or you can take any VB. This is your VC and this is your V. Already you know V is equal to 0 because emitter is connected to the ground. So voltage at the emitter point will be 0. And VB how to find out? Because VB how to find out? Because already you know VB is equal to VB minus V. Now V already is 0. So VB is equal to VB. Similarly VC you can find out. VCE is equal to VC minus V. Now V is 0. So VC is equal to VC. And other approach also there. VC also you can find out. VC already you got VCC minus ICRC. Any method you follow, so you'll get same voltages. This is one method based upon this circuit, and based upon also you can find it out. Then next is VBC. So VB you got, VC you got. So VBC is equal to VB minus VC. Everything is clear?
Yes, sir.
Yes, sir.
Okay. So next one is you have to draw the load line or output characteristic or load line you have to draw. So for that, what you have to do? So so let me show there. Now same thing. What I have done. The steps are there to find out the values. First you've got IBQ using that formula. Then ICQ. Then VCQ. Whatever values are given, you can put those values, and it is given in your book also as an example. You can do it. Now VB is equal to VB, same thing, 0.7 volt. VC is equal to VC 36.83 volt, and VBC is equal to VB minus VC, and you can see this is minus 6.13 volt. So can you tell me why it is minus? VBC. What is the significance of negative sign here?
So that means VC is actually
Reverse
greater than
bias.
VB.
Reverse biasing.
So that is a reverse biased. So you can see VBC, that's why output loop is reverse biased. So negative sign, or it is showing the polarity, accordingly you have to connect. Now load line you have to draw. So any point you can take. For that you have to take the output characteristic chart, or otherwise you have to plot a different BC value, what will be the IC. So if this blue line already available with you, so now we have to find out the load line. So main point, you have to find out the maximum voltage and maximum current. So that formula, output KVL already we have seen. So VCC minus ICRC minus VC is equal to 0. So if you're putting the maximum, because when you will get maximum VC when IC is equal to 0, and VC is equal to VCC. So VC max is equal to VCC. Similarly, when VC is equal to 0, so IC maximum is equal to VCC by RC. So these are the maximum voltage and current you are getting. So then we have to plot that point. This is maximum current, so IC maximum also you can tell, or IC saturation. Similarly, VCC, this is your VC maximum, or this is your maximum supply voltage. So whenever it is crossing any IB current values, that is known as Q point. And corresponding Q point, you can write ICQ and VCQ. So whenever it was asked to plot, so corresponding IC and VCQ already achieved. So you have to see already IBQ also you have done. So you can write in this graph. So what is IB you got? 47.08 microampere. So here you can write 47.08 microampere. Similarly, what is ICQ and VCQ? You have achieved 6.83 volt and 235 milliampere. So here 2.35 milliampere and 6.83 volt. So this chart, sometime it was asked to draw the characteristic or load line. So you have to do this way. So in some question also you can see, for example, operating voltage and current will be given, and it was asked to derive what are the resistances values. So you see, equations are same, methods are same, but you have to see what values are given and what values you have to find it out. Or sometime it will be asked, based upon these values, design the fixed biasing circuit. So then what you have to do? You have to derive, or you have to calculate base resistance value or collector resistance values. So then once you got these values, then you have to design the circuit, and accordingly you write their achieved values, you can put it there. So a similar question you can see in your book or exercise, but method is same. What are the steps I told, you have to follow that. In that equation, you have to see what values are given and which value you have to find it out. I hope this part is clear to everyone.
Yes, sir.
Yes, sir.
Okay. Now we are coming to our next method, emitter stabilized bias method. So if you have seen what is the drawback in previous circuit, here you can see stability will be little bit poor, because stability we'll see later on. So change in, already I told, change in output current. What is change in leakage current? So different empirical models are used. So they have seen, so stability is less. So to improve the stability, what we have to do? So another, you can see same circuit, only RE is connected. Okay, so this is the next method to improve the stability. One emitter resistor is connected across the emitter junction. So that's why it is known as emitter stabilized bias method. Otherwise, you can see the circuit is very much similar to previous one. Only this additional resistor is used. And you have seen earlier, because no resistors is there, so all current is flown to the ground. So that is the design point of view. You can see also whenever you calculate the stability, so which is lesser in case of earlier method. So to improve that method, so only I'm repeating many times, only one additional resistor is connected across the emitter. Okay, so the circuit, you can see same circuit. Now we have to do DC analysis. So what is the first step? Anyone?
Remove the capacitors, they act as short circuits.
Short circuit, okay. What we have discussed? Short circuit or something else?
Open circuit,
open
circuit, sorry.
Okay, 2 pi FC. So it will be it will be infinite. So it will be open circuit and this will be neglected. This is the first step for DC biasing. Okay. So first step you have to write in DC biasing technique or using DC biasing. So frequency is 0, so XC will be infinite. So that's why capacitor behave as open circuit, and AC resources can be neglected or you can make it 0. So that's why the new circuit for DC new circuit will be this one. So this is your first step. Then what is the next step?
KVL in the input loop, and we have to find IB.
Same whatever steps I told, same step you have to follow here. First you have to find out IB, second one will be IC, then you have to find out the VC. Okay, so here you can see, to improve the stability level over that fixed bias configuration, a emitter resistor R is connected between emitter and ground. Now you have to see the circuit, same thing. You can see, redraw the circuit. So here you can see VCC is given. So already if I'm separate, I'm taking two VCC supply voltage. So if I'm getting this is plus and this is ground, so I can make connection this like input loop. No? So I can make like this. So VCC and this is your ground. So similarly, if I'm applying this input KVL, so here you can see input circuit will be same thing. VCC will be there and this is your ground connected to this one. I hope the circuit is clear to you, or any confusion is there. So if you see other diagram also here, here I can take RC and I can take plus VCC. Okay, so the VCC is splitted now, so I can take like this. So this is your input KVL, this is your output. Because VCC is splitted for, because the same supply voltage is given to input and output, you can also split into two different parts. Because sometimes it may have different voltages, but here it is given same supply voltage are given to input and output. Okay, so for the time being you are taking the input loop, so I'm removing this part. So if you're applying the input loop or base emitter loop and you apply KVL, we have to find out IB values. So how to get that? So can you tell me what is the KVL here? Anyone?
VCC minus IBRB minus IR is equals to 0.
VB part you forgot. VB is also there.
Minus VB.
Minus VB also there.
Would be included in that equation as well.
So you have already told same thing, only because you can see, because in KVL you are applying the sum of the voltage should be 0, or you can see VCC, what is the drop across RB, IB into RB minus VB, because this is IE current, this is IE this is IB, and this is your IC. So this is you are getting that one. So IE into RE, because this is your IE, this is given IE. So apply the KVL, same equation, what you told, VCC minus IBRB minus BB minus IERE is equal to 0. Now here to IE you can convert to IB, because already you know IE is equal to IB plus IC, and IC is equal to beta IB. So I can write beta plus 1 IB. So in case of IE, you can put beta IB, or you can see already if you are taking beta is very much higher. So if I'm taking beta is very much higher than 1, so I can write also IE is equal to approximately beta IB. Okay, so now you can put in your equation IE is equal to beta 1 plus IB. So this new equation will be VCC minus IBRB minus BB minus beta plus 1 IBRE. Is it clear? I hope everyone is getting it. Any doubt anyone have? Am I audible to everyone?
Yes, sir.
Yes, sir.
Yes, sir. Audible.
Yes, sir.
Okay.
Sir.
So now one same equation we are writing, because we have to express this equation in terms of IB. So now you can see VCC is known to you, VB is known to you, and RBRE is known to you. So in that equation, we are putting these values, and we are writing IB is equal to VCC minus VB divided by RB plus beta plus 1 RE. So in somewhere in some book it is given beta plus 1, or sometime it is you can write beta RE also, depending upon that. But more accurate is beta plus 1 RE, because IE is equal to beta plus 1 IB. Okay, so whenever whatever approximation assumption when you are you are doing during solving, you can put it there, write it there. Like in exam you are asking in some diode it is not given, so you can also, for example, it's somewhere it is not given, you can take it, you can write I have taken this is as an ideal diode, based upon that solve. So there is no problem. Okay. Now once you got IB values, then next step is you have to find out what is my output current IC. IC is equal to beta IB. So once you got IB, so this is VCC minus VB divided by RB plus beta plus 1 RE. So if you see this is this expression, based upon this expression you can redraw your input circuit. So you can see voltage divider principle applied. So this input network you can write this one. So VCC, because you have to find out the current. So what I told, total voltages divided by total impedance. So here you can see VCC, you can see total voltages VCC minus VB, and total impedance is equal to RB plus beta plus 1 R. So this circuit already, because whatever input you have taken, you can redraw this circuit in this approach also. This is for this is not required. This is for your information only. Okay. So once you got IB, then we have to find out IC. First step, then you have to find out IC. IC is equal to beta IB. So now once you got IC, then we have to find out VCEQ. So where you have to apply the output KVL. So what is your output circuit? Once again you can see. So VCC it is there, RC and RE will be there. So now can you tell me what is the KVL here? Anyone? Hello, hello? Am I audible to everyone?
Yes, sir, you're
Yes,
audible.
sir.
Okay. So can you tell me what will be the KVL here? If we apply the KVL at the output loop. So you can see the current direction because supply voltage VCC is there. So current flow direction you can see. Apply using this, can you apply the KVL?
Sir, VCC minus RCIC minus VCE minus IR is equals to 0.
Now once again repeat. Hello?
VCC minus RCIC minus VCE minus IR is equals to 0.
Yes. So if you're taking from this approach also, you can write like the current direction is given like this, na? So whatever you told, same thing. So if I'm applying from this point, so this is ground. So ground voltage is 0. So then I can write IERE minus VC minus ICRC plus VCC is equal to 0. Same thing, what you told, same thing we can write. So that is also you have 10. IERE, you can take same thing, what you told. If I'm taking opposite side also, same thing, what you told. VCC minus IERE minus VC minus ICRC is equal to 0. Now here you have to come because here IE and IC, two different variables are there. So based upon you can take because IE approximately equal to IC you can consider. So then you can put IE instead of IE you can write IC. So then IC will be common. Then VC minus VCC plus IC into RC plus RE you can consider. So ultimately you will get VC is equal to VCC minus IC into RC plus RE. So if you remember the previous expression, there you are getting only ICRC, but here you can see another register you are using. So that due to that, what is that drop? So IC into RE. So additional one term you are getting due to emitter resistance. Otherwise, no variation you can see. Now once you got VC, similarly you can find out all the voltages VB, VC and VE. So now can you tell me what is VE now? Anyone? What is the voltage at the emitter point, emitter node, which is VE? Earlier case you have seen it was grounded, so that's why V is 0. But in this case, V is not 0.
IERE.
IERE.
V is equal to, so how you can find out V is equal to IERE. Then how to find out VB? So
VB minus VE.
VB is equal to VB minus VE. Now VB is equal to VB plus VE. Okay. So this is, you can use this approach and you can find out VB. And VC also you can find out VC minus VE. And V is also known to you. So you can write VC is equal to VC plus VE. So now all node voltages you are getting it. Similarly, this also you can derive, or you can write also VCC. VC is equal to VCC minus ICRC. Here also you can find out VB is equal to VCC minus IB RB. So any approach you can follow, and you can check whether you are getting same or different values. So in this circuit, each node voltages, current, everything you can derive. So once you got ICQ and VCQ, then you can derive IC saturation and VC saturation. Then also you can draw the load line. So can you tell me what changes will be there if you compare the previous load line analysis? So if you are doing here, what changes will be here, or everything will be same? So if you see, only changes will be because IC will be now, because VC is equal to 0, then IC is equal to VCC divided by RC plus RE. So your saturation current now you will get based upon this. You can see when I'm writing when VC is equal to 0, so IC maximum or saturation will be VCC divided by RC plus RE. So saturation current will be based upon your RC and RE. But your VC will be, VC maximum will be VCC, because when IC is equal to 0, so that time VC max is equal to VCC. Okay. So same thing once again every time, this all values. Now can you, based upon this, now can you solve this question? Find out all the currents and voltages, because this is a circuit based upon your emitter biased method. And do it. Okay, respond your ID numbers. One,
Present, sir.
2,
Present, sir.
3. Question already you have typed it or not? Hello.
Yes, sir. Question noted.
Noted.
No, sir. Please give me a few minutes more to jot down the question.
Okay. It is visible now?
Yes, sir, visible.
Okay.
Yes,
sir,
sir.
visible.
Okay, fine. So I'm taking your attendance. In between you can note it down. ID number 4,
Present, sir.
5, 6,
Present, sir.
7, 8,
Present, sir.
9,
Present, sir.
10,
Present, sir.
No, sir. 5 present.
11,
Present, sir.
12,
Present, sir.
13,
Present, sir.
14,
Present, sir.
15,
Present, sir.
16,
Present, sir.
17,
Present, sir.
18,
Present, sir.
19,
Present, sir.
20,
Present, sir.
21,
Present, sir.
22,
Present, sir.
23,
Present, sir.
24,
Present, sir.
25,
Present, sir.
26,
Present, sir.
27,
Present, sir.
28,
Present, sir.
29,
Yes, sir.
30,
Present, sir.
31,
Present,
Present,
sir.
sir.
33,
Present, sir.
34,
Present, sir.
35,
Present, sir.
36,
Present, sir.
37,
Present, sir.
38,
Present, sir.
39, 40,
Present, sir.
41,
Present, sir.
42,
Present, sir.
43,
Present, sir.
44,
Present, sir.
45,
Present, sir.
46,
Present, sir.
47,
Present, sir.
48,
Present, sir.
49, 50,
Present, sir.
51,
Present, sir.
52,
Present, sir.
53,
Present, sir.
54,
Present, sir.
55,
Present, sir.
56,
Present, sir.
57,
Present, sir.
58,
Present, sir.
59,
Present, sir.
60,
Present, sir.
61,
Present, sir.
62,
Present, sir.
63,
Present, sir.
64,
Present, sir.
65,
Present, sir.
66,
Present, sir.
67,
Present, sir.
68,
Present, sir.
69,
Present, sir.
70,
Present, sir.
71, 71.
Sir, I'm present, sir. Roll 5. I got disconnected at the time.
Okay, I did it. Okay, so anyone did this? Same step already equation derived, and you don't have to mug up the equation also. If you know the steps, then easily you can do for all the techniques. So same step for all the batching techniques you have to follow. So here for emitter biasing already you have derived. IB is equal to using this equation you can calculate. So you can see one important point. Always you can see IB will be in microampere because very small current. In calculation wise also you can check whenever solving any questions. So sometime due to units you may have done the mistake. If it is coming in milliampere or something different, then you should think once again. And this IB is always been microampere or less than that. Then once you got IB, then you can find out IC. Then you can find out BCE by using this BCC minus IC into RC plus RE. So you will get it 13.97 volt. So this is ICQ and BCQ operating output current and output voltage. On VCC, you can find out this expression. Already you have seen VCC minus ICRC. V also you can find VC minus BC. So you are getting V is equal to 2.01 volt. B is equal to IRE. So you are getting 2.01 volt. Same thing. You are using any approach. V is equal to 2.01 volt. VB is equal to 2.71 volt. VBC is equal to VB minus BC. So you can see you are getting negative, which is you can see it is you have to connect it reverse bias configuration. Now if you are going for load line, so already I told your saturation current will be VCC by RC plus RE, and VCC will be your maximum output voltage, and whenever it is crossing your any IB values, so that will be your Q point, and corresponding whatever values you achieve, you can note it down. So any queries anywhere, need any clarification required? Okay. Now another method is voltage divider biasing method. So here you can see earlier you have seen your VCC is connected through RB. Here you can see this input voltage is connected using two resistors, R1 and R2. So here you can see your voltage is whatever input voltage you are giving. So that will be divided using two resistors and R1 and R2. And you can see whatever R2 across R2, that voltage is provided or given to your input. So that is the method, voltage divider bias method. So this is popularly used compared to earlier two methods. So if you are doing this, you can see this is also given in your book. You can see the steps, whatever step I told, same steps you have to follow, and you have to derive all IB, IC, and other voltages you have to derive. So you now already time is over. So next class we'll discuss. But in between, you can go through the book and try to see the process how it is done. Okay. Am I audible to everyone?
Yes, sir.
Yes, sir.
Okay. So try to read by yourself and try to solve it. During, if you are reading that and you are confused, you are not getting it, then it will be easier to explain you in more detail. Okay. So please go through that. Okay. Any whatever today we discussed, any queries you can ask. Otherwise, you can leave the class.
Sir, in that last circuit voltage divider, R1 and R2 are RB values, means they are the base current resistors, R1 and R2.
No. Earlier RB is there, base resistor, that is replaced using two resistors, R1 and R2.
Okay.
So that's why, because your input voltage is divided now. So that's why that method, because every definition is in that name only. Okay, so simply you can see whatever VCC voltage you are giving, now it is divided in R1 and R2, because you will get two different voltages. Now if you see in the circuit, whatever R2 voltage you are getting, that will be act as your input. So that derivation I will tell you, or for the time being, for you, but you go through the book, and you will get many confusion may be there. So that time I will clarify you one by one.
Yes, sir. Thank you, sir.
Okay. Okay, I hope nobody have any questions. So I'm leaving the classroom.